Here's the continuation of the notes. So continue. We have a few more to do, maybe about 5 to 10 more minutes. So we were on number 12 here, which is number 12 from your book. You will be doing 11 and 13, so kind of watch how it gets done. I am supposed to graph the area indicated by the definite integral. So on mine, I've got a trig function here. And when we graph our trig functions, and if you choose Zoom trig, I think it's number 7 on your calculator, we generally, our standard window goes from pi over 2 to pi, and then 3 pi over 2, etc. And I'm making this a little elongated here because I can see that my limits of integration are actually from pi over 4. So I'm going to draw this in so you can see it to negative pi over 4. So I'm going to be squeezed between these two blue dotted lines. And my first function, or my y1, or f of x, I actually think I'm going to call it f of x this time, is secant squared x, which is 1 over cosine squared x. And I'm changing it to cosine squared so I can go on my graphing calculator and see what that looks like. And my g of x, the one that I'm subtracting, is cosine x. So I'm going to go graph both of these. I think I'll do the top one in red. And you can go enter that on your graphing calculator if you would like. And what you'll see is that it hits here at 1, and then it runs like this, and it actually runs asymptotic at pi over 2, which should make sense to you because pi over 2 is where cosine 0, so I have an asymptote there, a denominator of 0. So I'm looking, oops, sorry I missed it. I'm looking at this portion of that graph. I'm going to do it a little bold there. And my cosine graph, you should know what cosine looks like. It starts at 0, 1, and at pi over 2, it's at 0, and it just kind of waves along like this. So the area on this one that I'm in search of, the area between the two graphs, between the red one and the blue one, would be this little piece here and this little piece right here. And again, you're allowed to use your graphing calculator in these to help you out. I'm not sure what the question was for that one, so I'm going to move down here to example 2. So on this one, the graph has been sketched for you, and this is generally how you'll see it on AP. They'll have a graph sketched. They'll tell you what the functions are. They'll generally shade in the region. But this is really important. Don't rely on your graph to find those intersections. Don't rely on the graph, and here's why. Generally what will happen is the intersections will be unclear from the graph. Now I can see it looks like it's intersecting at 2, and I could guess and plug it in and see if 2 gives me the same value on both of these, and it looks like this one's about -3, but we never guess. What you do is algebraically you set them equal and solve, or if you're allowed to use a graphing calculator, you enter them both, the one under y1 and one under y2, and you calculate their intersection. So this one, we're going to go find those intersections. Where does the green graph equal the red graph? And to solve a quadratic, we get it equal to 0, and we always like that x squared term to be positive. So I'm left with this quadratic, which is factorable. If it weren't factorable, I'd have to use the quadratic formula. If I didn't have a calculator, again, if I had a calculator, I would just calc intersect using my graphing calculator. So this one factors nicely, and I can easily see that this implies that x is at -3 and at 2 is where my intersections occur, which jives very well with my graph. So I am going to set up the integral to find the area between them, and again you would shade all this in. It's hard to shade on a smartboard. I really like it. I think I have an option. I'll find it later. Alright, so I am integrating, and for this entire interval from -3 to 2, between the two intersections, the green function is on top. Keep in mind if at any point they shift, like right here, the red one starts to be on top. If I'd gone out to 4, I'd have to have another summation where I add with the red one on top. But this one, the green function's on top, and that was my quadratic function, 6 minus x squared, so that goes first, minus the lower function, which was my line, which was y equals x, and this is what I need to integrate. And you could, again, if you had your graphing calculator, you would math 9. I am confident that you also know how to do that by hand, so we are going to move on to the next problem. Example 3 on the next page. So once again, I've got two functions. I've got the sine function, which is the red one. I know that the sine goes through 0, 0. That's something you should memorize. And cosine function, which is the blue one. I'm to find the region bounded by the graph of x equals 0. Well, that's the y-axis. And the first intersection, which is right here. So you'll notice on that entire interval, the blue function is on top. So I'm actually looking for the area from the green line to the green dot. Right there. And the blue function's on top, so that'll come first in my integrand. Now, this intersection right here, where is that? Well, that's where sine x equals cosine x. And we know that they're equal at 45 degrees, or at pi over 4. They're both root 2 over 2. So I know this right here, that intersection is pi over 4. Well, why do I need that? Well, that's the outer limit on my integral. So I have to say that my area is equal to, my lower boundary is 0 because they told me it's bound by the green line. It's also bound by the first intersection, which is this green dot, which is pi over 4. Then top function comes first, that's the blue one, my cosine function, and then my sine function. And I'm going to integrate that. And I'm going to take this one by hand. Remember, if you're in doubt with your integration, remember it goes s, c, negative s, negative c, oopsie, s. And so if you have a hard time remembering, I usually don't use this. I just quickly take the derivative. But if I were to say what's the integral of cosine, you would say, well, that's sine x. So I'm going to do this one by hand. The integral of sine is negative cosine, but I'm subtracting that. And you should do a quick check on this just to make sure. Derivative of sine is cosine. Derivative of cosine is negative sine, and it matches. And I'm integrating that from 0 to pi over 4. Now, you might be tempted just to leave this 0 off, but with trig functions, remember, like the cosine of 0 is actually 1. It's not 0. So I need to say that this is the sine of pi over 4 plus cosine pi over 4. First upper boundary and first minus the lower boundary, sine 0 plus cosine 0. And this is where people often make a lot of sign errors, so I wouldn't skip any steps. The sine of pi over 4 is root 2 over 2, as is its cosine, minus sine 0 is the y value at 0, which is 0, right? Plus cosine 0 is actually 1. So that's what I've got going here. Now, root 2 plus root 2 is 2 root 2 over 2, which is, that just is root 2, and this becomes minus 1. And this is my answer. If, again, you have a calculator, you could go take and math 9 that, and it'll give you the decimal form of this answer. But I'm confident in that one, so I'm not going to go check it. So the last one I'm going to do, and then we are done with notes until tomorrow. We'll take a few more, and then have primarily some work time. So my last one here, what do I have? I've got a cubic, and I've also got a quadratic. I think I'll color code them here for you. I've got the red one, and I've got the blue one. And keep in mind, if at any point they switch from red on top to blue on top, you're going to have to split this up. Well, you need to find these intersections, because on this first interval from here to here, the red one's the top function, but then from here to here, the blue one's the top function. So I'm going to have to set up two different integrals, one in this region and one for this region. Well, I need those intersection points. And again, don't rely on the graphs. Rely on your calculator if you get to use one. Do calc intersection. If you don't get to use one, you're expected to know how to perform the algebra. So we're going to set the two functions equal. And we are going to go solve that. And to solve them, we need to get one side equal to 0. The x squared terms cancel off, so I think I'm just going to move everything over to the left here. I'll subtract the 4x, and I'll get a minus 18x, and that'll equal 0. I'm going to factor out a 2x, and I get a nice difference of squares. This would imply that x could equal 0 or plus or minus 3, which just does jive with my graph. Here's my intersection at 0, negative 3, and at 3 likewise right here. So now what do? Well, I have to set up two different integrals. The first one, like I said, is from negative 3 to 0. And from -3 to 0, the red function is on top. And the red function is 2x cubed minus x squared minus 14x. And the blue function is the one on the bottom. And that one is 4x minus x squared. Okay? And that'll give me the area of this blue stuff right here. And let's do proper notation. Let's put our brackets down. Then I'm going to have to split it up because I've got it going from red on top to blue on top. So in my next set of limits, I will go from 0 to 3. And in this set, the blue function, which is 4x minus x squared, comes first, followed by the red function, 2x cubed minus x squared minus 14x. Now, and again, I should use good notation here, the whole thing with respect to x. All right. So, now cleaning this mess up, I'm not going to take it all the way out, but I'm going to tell you, you did a lot of work out here. You already subtracted this one from this one. And we got 2x cubed minus 18x. So I already know, I have no sense doing it again. I've got 2x cubed minus 18x. Then I'm integrating from -3 to 0. Plus, likewise, don't reinvent the wheel. Over here, I just swapped which one came first. And in math, when you take 5 minus 3 and then you swap which one comes first, what you get is a pair of opposites. And that's going to happen regardless how ugly your pieces are there. So when I'm just simply swapping these, what happens is I'm going to get the opposite of this. So I would get -2x cubed plus 18x. Or you could call it 18x minus 2. Or you could do it all by hand too, but trust me, it's going to work out. And I'm going to be integrating that from 0 to 3. And I'm going to stop there from there. You would know how to do it by hand, and if you had your Math 9 option, you would choose that also. I believe that's the last one I want to do, so we're going to end the video. This is where we'll pick up with tomorrow. And you guys have a great day, and if you want to, you can go start that homework. It is on your calendar. I'll write it down here for you. If you don't want to get too far behind, it's going to be, you could start page 454, 1 through 33 odd, 73, 74, but don't try, if you're going to go tackle a couple of this, don't try 13 yet, 17, 31, 33, 73, or 74. You will not know how to do those yet. And we're done.